morning, everybody. This is sudhakar, HOD Physics, KGRL College. The Department of Physics established by 1981 in our KGRL College. Now we are going to discuss about the topic basics of physics. First of all of you know about physics. First, what is the physics? What is the physics? Everybody first know, and after we are going to the basics of physics. Now, the physics is study of how the universe behaves. Physics is an experimental science, and lot of definitions we have physics because physics is study of matter, the moment of matter, that matter through the space and time of the universe. Physics is the study of nature around the world. Lot of definitions belongs to the physics. We study the everything in our universe and in our earth. Those belongs to the physics, because the study of physics is classified into two types. One is short range study of physics, one is long range study of physics. The short range study of physics is called microscopic study of the physics. The long range study of physics is called macroscopic study of physics. That is called astronomical study of the physics. Okay, now we are going to look into microscopic study of physics. The microscopic study of physics, we already said, it is short range study of physics. It deals with microscopically small mass of particles. It deals with microscopically small mass of particles, like atoms. This is also atom. This is also atom. Every atom has a nucleus. This is nucleus. Every nucleus have protons and neutrons. Here protons are positive charge, neutrons are chargeless. Electrons in atom always revolve around to this nucleus. Electrons are always negative sign. Okay, the nucleus always have positive charge and attractive force. These nucleus releases attractive forces. These attractive forces are attracted to nucleus for every element, every particles in atom. Now we are going to the full structure of the atom. The study and observation of the small microscopic particle, what happened in the inner wing and outer wing. Now we are going to brief observation in atom. Atom is this is atom. Every atom has nucleus. The electrons in atom always revolve around in this nucleus. Why? Because the nucleus have heavily positive charge particles. Those are protons, neutrons. Here protons have only charge, positive charge. Neutrons are chargeless particles. Because we know the size of atom is 10 power of minus 10 meter. The nucleus size is 10 power of minus 14 meter. And as well as the proton in nucleus, the proton size in atom is 10 power of minus 15 meters. As well as the quarks in the part of protons. Okay, the quark size is 10 power of minus 8 meters per second. Okay, now we clearly know in what is the structure of atom on inner part and outer part of the nucleus. Okay, now we are going to isotopes. How microscopic particles study and express to this is isotope. This is protonium, deuterium, like that. Now we are going to protonium, deuterium. Now we are looking into the hydrogen atom. We are looking into the hydrogen atom. Every hydrogen atom had only one atomic number. The isotopes are depended by the mass number only. We are looking to this diagram. Here, plutonium isotope is made by only this type of hydrogen atom only had one proton number only in this nucleus because it is plutonium. Here we look to the helium. Here the nucleus have one proton and one neutron because the mass number is 2 because this type of isotope is called plutonium. Now we are looking into the another plutonium. Here the nucleus of hydrogen atom had 3 particles, 1 proton, 2 neutrons. The mass number is 3, but the atomic number is same in this isotope. Why I am calling this is isotope? Now we are going to the isotope, isotope. Now we look into this equation, this elements. We look into this elements. Here carbon element always have the atomic number is 6, but their mass numbers are same. Yes, this type of elements are called isotopes because I call these are isotopes. Like plutonium, depended by their mass number. This is plutonium, this is plutonium, this is plutonium. As well as now we are going to isobar. Isobar here we observe these elements carbon, nitrogen, oxygen. Here carbon atomic number is 6, nitrogen atomic number is 7, and oxygen atomic number is 8. Now we are clearly observing this elements. Here atomic numbers are must same, but their mass number is same for all elements. 14, carbon mass number 14, nitrogen mass number 14, as well as oxygen mass number 14. Now we are going to macroscopic study of physics. Macroscopic study of physics, we already said it is long range study of physics. It is long range study of physics. The microscopic study of physics is a long range study of physics, like astronomical study of physics, like that. Now we are looking into this slide. This is astronomical study of physics, deals with universe like galaxies. Our universe have number of galaxies and nebulas. We are lived in one galaxy, that is Milky Way. Milky Way is our galaxy. In this Milky Way have lot of solar systems. One of the solar system we are living. This is our solar system. Our solar system is formed by one sun, 8 planets, 5 dwarf planets, 170 moons. Before 2005, we have 9 planets. But after 2005, 2,500 scientists gathered together at capital of capital of Czech Republic country. They are removed a planet from the list of solar system because we have 8 planets only. Why? Because they are removed a planet from the list of solar system. Here the Pluto is irregular orbit and is very far from sun and is very low atmosphere having because they have no characteristics about the planet because this is removed from our planet's list because we have 8 planets only. Okay, now we are going to observe our galaxy and solar system in our universe. The lot of solar systems, the lot of galaxies having there. Okay, this is the brief note about physics. This is brief note about physics. This is called physics. The study of observation microscopically, the study of observation macroscopically. physics is called physics. Okay, because the study of everything is called physics in long range or short range, because that is the called physics. Now what is the physics? Now we are going to the basics of physics. All of the following basics units of physics. We have 7 fundamental quantities of the international system of units. Now we are going to 7 fundamental quantities. There are mass, length, time, current, temperature, amount of substance, luminous intensity. Mass is denoted by small m, length is denoted by m, time is denoted by t, current is denoted by I, temperature is denoted by T, amount of substance denoted by m, the luminous intensity is denoted by L. Now we are going to discuss about the mass. The quantity of object. The quantity of object first found in pounds, after that it is converted into grams and kilograms at 1960s. Okay, the mass of SI units is kilogram. CGS units are centimeters. Now we are going to market. You brought some vegetables, some items. How to ask? Please give me 10 tomatoes. Please give me 10 potatoes. Not like this. We asked to seller, please give me half kg potato, 1 kg potato, 3 kg potato, 100 grams seeds, something like that. Because it is a first fundamental physical quantity. Now we are going to the length. Length is measured by the distance in between any 2 points. The units of the SI units of the length is meters, and the CGS units are centimeters. Now we are going to the time. Time is observation of any two points. Observation, time interval, observation, any 2 points are often. It is the SI units of the time is always seconds for CGS or SI. Now we are going to current. Current is the flow of electrons is current. The flow of electrons is current. Here, the SI units of the current is ampere. It is denoted by A, and as well as the temperature. Temperature is as well as temperature. Temperature is like that. The observation of the measurement of a body, it is cold or hot. It is expressed to that is cold or hot because it is denoted by T. The SI units of temperature is Kelvin. Symbol is K. Symbol is K. Now we are going to discuss about amount of substance. Now we will measure a room of temperature, a room of molecules. How much molecules have in room or a vacuum tube, anything. That is measured by a amount of substance. It is the SI units of it is mole, and luminous intensity. The light intensity is measured by luminous intensity. The SI units of the intensity is candela, CD. Okay, these are the 7 fundamental physical quantities. These are the 7 fundamental physical quantities. Now we are looking into another fundamental physical quantities, and these are called derived fundamental quantities. Why? Because these are called fundamental physical quantities. These are derived from 7 fundamental physical quantities because these are called fundamental physical quantities. derived physical quantities. These are called fundamentally derived physical quantities made by fundamental physical quantities, because these are displacement, area, volume, speed, velocity, acceleration, force, energy, density, moment, power, work, momentum, pressure. Now we are going to the displacement. Displacement is the shortest distance traveled by a object or body. The shortest path traveled by an object is called displacement. Displacement is always denoted by x or b. The SI units of the displacement is meters. CGS units are centimeters. Now we are going to discuss about area. Area of a surface, area of a room, area of a table. Like that, how we measure area. How we measure to area. Now we are going to the area. Area is defined to the product of length into breadth of Okay, it is denoted by calculate. The SI units of the area is meter square. The CGS units of the area is centimeter square. Now we are going to volume. Volume of a tube, volume of a room, volume of a space, anything, space like that, rooms, like that. How to define volume? Volume is the product of length into breadth into height, because the SI it is denoted by actually the SI units of the volume is meter cube. Now we are going to the speed. Speed is defined by S. How it defined? The total path length traveled by the total time. It is called distance. Okay, distance. How to define speed? The time taken for total distance is called speed. The SI units of it is meter per seconds. CGS units are centimeter per seconds. Okay, now we are going to velocity. Velocity is when we will find the rate of change of displacement is called velocity. The rate of change of displacement is called velocity. It is measured by the SI units of the velocity is meter per second, as the speed. CGS are centimeter per second. Now we are going to the acceleration. Okay. Now we are going to discuss acceleration. It is the rate of change of velocity. The rate of change of velocity. With respect to, we define velocity, speed, acceleration with respect to time. Now we will discuss acceleration. Acceleration is denoted by n. The SI units of the acceleration is meter per second square. CGS units are centimeters per second square. Now we are going to discuss force. Force is defined by Kepler. Or denoted by Kepler. It is defined to the product of mass into acceleration of a body. Mass into acceleration of a body. Because the units of mass is kg. Acceleration is meter per second square. Kg meter per second square for SI units per force. V is kg meter per second square is denoted by newtons. Totally the SI units of the force is newton. The CGS units of the force is dynes. 1 newton equal to 10 power 5 dynes. Okay, now we are going to look into the energy. Energy is ability to do work. Energy is called ability to do work. It is denoted by E, defined by it is ability to do work. Okay, the SI units of the energy is joules. The SI units of the energy is joules. Okay, 1 joule equal to 10 power. SI units of the joule equal to Newton meter, and 1 joule equal to 10 power of minus 7 ergs. Ergs is the CGS units of the energy. Okay, now we are going to discuss about density. Density is the unit mass per volume, and m by b. It is density is defined by m by b denoted by rho. The SI units of the density is kg per meter cube. Kg is SI units of meter mass. Meter cube is SI units of volume, because kg per meter cube. Okay, like that. The CGS units of the density is grams per centimeter cube. Okay, now we are going to momenta. Momenta is denoted by capital T. It is also as like as compared with the energy, and the SI units of energy and momenta is same, Newton meter. Okay, now we are going to the power. Power is denoted by capital P. The definition of the power is work per unit time. The SI units of the power equal to watt. 1 watt equal to Newton meter per second. It is energy work by Newton meter per second means joule for T. And power equal to work by T. The work per unit time. Units of work is 1 joule. Joule per second means power. Okay, it is denoted by W. Power is denoted by P. The units of watts equal, it is Newton meter per second. Now we are going to work. Work is denoted by omega or W. Here the definition of the work is the product of force into displacement. Displacement means it is denoted by S or X. Displacement is always the SI units of meters, and force is always the SI units of the force is the kg meter per second scale. Now we are going to discuss the force kg meter scale per second scale. Here kg meter per second scale is Newton, because Newton meter. Work is the SI units of Newton meter, as well as now we will discuss about CGS units of the work is 10 power 5 into dyne centimeter. Now we are going to momentum. Momentum is denoted by small p. Here the definition of momentum is the product of mass and velocity. The SI units of the momentum is kg meter per second, and it is denoted by ns and Newton second. Now we are going to discuss about the pressure. Pressure is denoted by P, defined by a unit force per area. A unit force applied per area is called pressure. The SI units of the pressure is Pascal. P equal to Newton per meter square. Why? Because the force by area is called pressure, because force is the SI units of the force is Newton, area is unit scale, because this is the derived physical quantities. Derived physical quantities are derived from fundamental physical quantities. Okay, this is the basics of physics. All are follow these fundamentals of physics to after to understand easily physics. Okay, bye. See you later.